Okay, this lecture will go through how to use the BLAST program. Okay, so what does BLAST really mean? Okay, later I'll explain to you. So the content is over here. How we're going to blast, okay? How to blast over internet using Python, how to pass, okay, because after you blast the whatever sequence you have using your Python, they give you output. How do you read, so-called read, okay, or pass the output will teach you, and what is the important or summary output, okay, result that you want to achieve. Okay, we'll go through that as well. And what does the blast record class give you? Okay, so BLAST means basic local alignment search tool. So what does it do? It will find region of similarity between biological sequences, compares nucleotide, okay, nucleotide, that's a typo, nucleotide or protein sequences to sequence databases and calculate the statistical significance. So in this lecture, we'll learn how to run BLAST in the web browser and run BLAST using Python, and lastly to pass the BLAST output. Okay. So 3 key information you need to know before you're running a BLAST. So first one is what BLAST program, okay, are you using for your search? Okay, there's 5 types over here. Okay, so the databases that you want to search against, okay, then your inquiry sequence. So what is the sequence that you're looking for lah? Okay, so what are the BLAST programs you look out for? BLAST N, BLAST P, plus BLAST X, T BLAST N, T BLAST X. What does each one of them do? BLAST N will take in nucleotide, okay, then we'll look at, and you search database nucleotide. They will find all the similar nucleotide that you have for your inquiry sequence. Okay, later look at example. BLAST P will give you, so you put in the protein sequence that you want to find, see whether in the whole database of all the protein sequences, is there any similarity between the one that you're inquiring with the all different database that you have from database of proteins that you have find out up to now. Okay, BLAST X you need to input a nucleotide, then okay, they will search through all the protein, okay, from all 6 different reading frames. Okay, 6 different reading frame, referring to, remember last time we learned the 0 start from frame 0, frame 1, frame 2. Okay, that's 3 of them. Then the other 3 will come from, if you look from the behind. Okay, go to the end of the sequence, then you look from 0, 1, 2, from the behind, then you look backwards. Okay, the reverse of it lah. Okay, then T BLAST N, you put in the input, they'll give you all the nucleotide from 6 reading frames that's similar. Okay, and T BLAST X, you put in the nucleotide from all 6 different frame reading. You put in the nucleotide, and they'll treat the nucleotide and read from all 6 different reading frames and give you, okay, and search the database, okay, in the nucleotide, all the nucleotide, and give you from all the 6 different data frame, okay, reading frame, all the nucleotide. Okay, mostly we're going to use just these 3 only lah. Okay, but there are cases that we can use for the rest. Okay, suppose that you have a nucleotide sequence GI number of this number, and you want to search it against the nucleotide database using BLAST N. So we go to this website. Okay, so these are the steps. Okay, go to this website, click on the nucleotide BLAST image, then okay, do the following: key in the GI number, okay, set the nucleotides collection in the database under the choose search set. Later I'll show you the image. Then after that, somewhat similar, so BLAST N under the program selection, then you click on BLAST. So we look at this. So key in over here, okay, the GI number, you see choose search set, okay, the database, click over here, okay, under others. Then for program selection, use this BLAST N. Then after that, click on this BLAST. Then the result will come out. Okay, graphic summary will show you distribution of the top 100 BLAST hit. So this one will show that, okay, have find similarity. Okay, for this one, okay, they realize from I think 80 plus to near 700. Okay, this sequence of 1000 plus sequence, okay, there's a short segment region that they can find similarity against the other nucleotide sequence that can be found in the database. Okay, then these are top 100 one. Okay, and under the description, to give you the description of all the blast hit. Okay, so this one is the name. I give you a mechanism. Okay, and the E value. E value is the statistical significance. So what does it mean? The lower the E value, the lower the probability that the similarity between the blast hit and the inquiry sequence happen by chance. So what I mean? Okay, in summary, in layman term, okay, simplified term, you just say the lower the E value, the more so-called the more similar it is for this sequence, okay, is to the inquiry sequence that you look at from that region you are looking at. Okay, so alignment, this one will show you the alignment will show all the similarity between the blast hit and the inquiry sequence. Okay, so this inquiry from the 7 sequence nucleotide, then compare with the subject that they are, which is this one. Okay, here are the similarity, and those without the dash is the non-similar one. Okay, so they give you the length, how much you pair up until, okay, and stuff. Okay, and the p-value and stuff. Okay, the e value, okay, which is your expected value. Okay, which is p value, okay, the e value. Okay, so just now what we did is using blast in a web browser, so you can use Google Internet Explorer. Okay, but BioPython has a inbuilt function we call QBlast, which is to call the online version of Blast using BioPython. Okay, inside this module. Okay, NCBI www. Okay, note that there are 3 compulsory arguments that you need to key in, which is the same 3 compulsory module key things that you need to know, key pieces of information you need to use before running a blast. So these 3 are the same. Okay, you need a blast program, you need to search under database you're searching against and inquiry sequence. Okay, there's a few other optional arguments which you may want to use. URL based means what the URL they are looking at. By default, you connect to NCBI. There's other database that you can search under, okay, website that you can run blast under, so you can go Google and find out. The format type, okay, choose the format of the blast output or the result will come out. By default is XML, okay, and expected is set the E value threshold. Okay, what's the threshold they're looking at? Okay, suppose that this is the same scenario. Okay, the GI number is the same, so look through this. So how do we run through using BioPython? Okay, so we need from bio.blast this package, you import this ncbiwww and run it. Okay, so this one result handler and QBlast. Okay, this is the program we are running. This is the database, this is the ID number. Okay, so I run. Okay, so this one will save it under this result underscore handle. Okay, this is if you got ID number. However, if you got a FASTA file that contain the sequence and the ID and stuff, you can also use it, okay, to help us blast over, use blast. Okay, you can read the file, open and read the file, then after that, okay, save it under FASTA underscore string or anything, whatever name you want, and instead of input the ID name, you put in the string, the FASTA string that you have read. Okay, you also can put in a FASTA file straight away, okay, by reading, okay, or you pass the file accordingly. Then after that, you find the dot sequence, so means you put in the sequence itself as the so-called ID. It's not necessarily its ID number. You can put in sequence as well. Okay, so this one, if you got FASTA file, these are the 2 options that you can use to open and read, or to straight away pass the file, then put under the sequence and use it as an argument in your QBlast. Okay, after running QBlast, okay, you get back a result, and by default it's XML, as I said before. It's useful for you to save a local copy so that when you debug the code, okay, you don't need to rerun the online search again and again, because sometimes the online search, you look through all the database, it will take quite some time. So what you can do is you save the file by writing the file. Remember we learned it last term, okay, and this is a file location, so I name it under my underscore blast. Now after that, what do you write? Write the handler, dot read, which is the handle is this one. Okay, read it. This one will appear the number of words that I key in. Okay, then close it. Okay, if you're not using it anymore. Okay, if you are still using it, don't need to close. Okay, so after getting the blast output in XML format, okay, either through searching NCBI website, which through a web browser, or running a blast over internet using bio button, which I went through with you in the past few slides. Okay, we are ready to pass the output to analyze the result. Okay, of course we first, because just now we close, so let us open the file again. Okay, remember we save this file. Okay, the blast output. Okay, after that, for single and multiple, okay, is the same as what we have learned in the sequence IO. One is use read. If you got single blast result, use read. If you got multiple, use pass. Okay, but before you use this, you need to import this NCBI XML. This one is the package or the module we're gonna use in order for us to pass a blast output lah. Okay, so these two are the same thing, just that this one single record, this one multiple record. Okay, inquiry record. So similar to sequence IO, you can iterate over the pass output using the following way, using the next function. Remember we went through this. Okay, so next. Remember this one does not save inside memory, it's just an iterator. So do whatever thing. Okay, next, then you give you a first record, then second record, third record and stuff. Okay, when you hit the last one, it will give you no further records. Same for your sequence IO. Okay, or you can use a for loop, or you can change it to list. Same for your sequence IO. Okay, now we have learned how to pass a record. Now, how do we analyze and find the important information over here? Okay, the diagram below shows the class diagram of the blast record class, represent all the information in a blast report. Okay, so in a blast output, there's description, there's alignments, and multiple alignment. So for description, it will give you a title, the score, the E value, then the number of alignments. Then answer alignment, they'll give you title. So this is the class, then this is a subclass, then this one even subclass. Okay, so it's just like attribute like that. So you can later you through example you see what it mean. Title length and the HSPS. Okay, so these are the things that we need. Okay, they have. They have. Okay, so all these are the information that contain in the blast output for each single output lah. Okay, so we'll let us use this following example to see how we get some information out of the blast record. There is a lot of more information that you can get depending on what you want and what you need. Okay, so let us, for this example, let us print out some summary information about all the hits in our blast report. Okay, that is less than a particular E value threshold. So E value threshold I set at 0.04. Anything that's less than 0.04, then I will print out. Okay, so for alignment, okay, in the blast record dot alignment, so what you do, so remember the alignment, so you look through these. Okay, so look through the alignment, so each alignment, okay, for the HSP in alignment.hsps, so you look through, so this one is the first loop, this one is the second loop. What do you look through here, so you look through all these. Okay, if the HSP, okay, aspect, which means the expected value, okay, with a p value is less than 0.04 for this one, okay, then you print out this alignment star, then print sequence, okay, the sequence title, then the length of the sequence and the E value of it, then you give you the inquiry sequence from 0 to the 75, okay, which is the very first nucleotide to the number 75th, okay, then where it matches and the subject that you hit. Okay, what are the things that hit? So the output will be like this. Okay, alignment. So this is the sequence they hit. This is the very first. They always look through from the lowest p value, E value, then from there, then the lesser E value, the better it is. Treat it as this. Okay, so E value is this. So these are the inquiry one. Okay, then this is the sequence that you input lah. Okay, this is the matching one that they have. Okay, so this one extract from where? From this one. Okay, from this sequence. So extract, they realize, over here there's a lot okay, of matching pair, okay, where it match, where it never match and stuff. Okay, I cut off after 75, remember. Okay, so these are the output, I mean. Okay, so there's a lot of different output. Okay, so this is just one example of what you can extract from the bus output. Okay, there are a lot more different information you can extract out of it if you clearly understand what is this one, depending on what you want and what you need. Okay, so next time you may need to read a bit more on how do we get all this. Okay, so this is just one typical example that how we find the summary report of all. Okay, so run the program yourself, don't just listen to the lecture, run the program yourself, then you understand what is it about. Okay, then from there, yeah, any question you can ask during the tutorial itself. Okay, so yeah, that's it for this lecture. Thank you.